Hi, thanks for watching Science with Mike. Today we're going to, what? We have intro music now? We've never had intro music. I'm cool with it. Okay, no, can we just do the intro again with some more upbeat music? Let's just do that again. Thanks for watching Science with Mike. Today we're going to talk about gas, pressure, and volume. Boyle's Law. Boom diggity! Today we're talking about the relationship between gas, pressure, and volume. It's called Boyle's Law, named after Robert Boyle, a scientist in the 17th century who studied this. And trust me, Robert Boyle knew a lot about volume. Check out dude's hair.
Oh my God!
Voluminous. Anyhow, what's pressure? Pressure is easy to explain. It's the result of collisions of molecules with the sides of the container. Now what I do next, students, you can't try on your own. I just winged a marshmallow at the blackboard and it caused a collision, and that collision had a force due to its mass and its velocity. Now check this out. I just winged 3 marshmallows at the blackboard, 3 times as many collisions, 3 times as much force. Now think of this. If it's a container of a gas, there's more marshmallows than you can imagine, and they're colliding with the walls of the container at all times. So, Boyle's Law is that pressure times the volume is always a constant number, which means if you have high pressure, then you must have low volume. And if you have low volume, high pressure, obviously. And if you have a low pressure, that's high volume. So there's an inverse relationship, and I'll show you right now. Check it out. This is one of the gas pressure sensors that we attach to these units we use in the laboratory. And as you can see, I've opened it up to the air. This is air in there, 20 milliliters of air. And it's about what atmospheric pressure is, a little bit under 1 atmosphere. And if I squeeze on it, down to 15 milliliters, you will notice that there's more collisions happening because the gas molecules have less room to roam. And if I squeeze even more, I can get it up to about 2 atmospheres. And as I've basically cut the volume in half, there's twice as many collisions happening. Real simple. You can understand gases using nothing more than your imagination. They're just particles flying around hitting stuff. Now next, instead of changing the volume, we're going to change the pressure drastically by lowering it using something we call a vacuuminator SCC1. All right. So what's going to happen is we're going to turn this motor on, and it's going to pump out most of the pressure in here by removing all the air. Real strong piece of glass in here. And so I thought where we'd start would be just with a small balloon to show you what this thing can do. And I probably should throw on my safety glasses because a vacuum's always somewhat possibly dangerous. You could have an implosion and things can break. So here we go. Just a little balloon. There's a little valve in there and I don't want them to get sucked in. And we will turn it on and you will witness the sheer power of the vacuuminator SCC1. There's a little pressure gauge here that shows the difference in the pressure. That's in inches of mercury and also in centimeters of mercury. So when this gets over towards 76, that means we've pumped out most of the pressure. And now you see that, that's really expanding because the pressure is low. Let's see if this thing will pop. Right now we're down to about 1/5 of the atmospheric pressure. And I would say it's probably safe to say that thing has gone up 5 times in volume. Let's see how much we could go here. The vacuuminator also kind of sounds like Willy Wonka's car. And we'll just let some air in there. Raising the pressure, lowering the volume. There, I cheated by pulling the stopper off. Next, let's do something exciting. Shaving cream. Whipped cream. Good. As we drastically lower the pressure, we'll see which one expands more. To be honest with you, I don't know. You can really hear the Vacuuminator SCC1 is laboring. Right now it looks like whipped cream's in the lead.
I forgot to put a beaker over the valve. Jeez.
It's about the limit of what the Vacuuminator SCC1 can do. Let's go back. Repressurize it. Now I got some cleaning up to do. And so you saw the massive amount of expansion. That's because shaving cream and whipped cream are basically suspensions with air bubbles in it. And by the way, that's why when I watch a science fiction movie and someone falls out of a spaceship and they don't blow up like a balloon, I'm very disappointed. Anyhow, what's next is we're going to do a plastic bottle, kind of crush it, get most of the air out of there, see what this bad boy does. Well, he's almost back to his full volume. Let's see if we bust it. Oh, it's at its normal volume. I'm scared. Now we're pretty close to full strength. Looks like it's going to handle it. We've pumped about 9/10 of the atmosphere out of there. Let all the air back in. Yeah. Small little golf pencil. Let's see what happens. And as you can see, the pencil has pretty much doubled in size. We'll let the pressure back in. And it's back to a little tiny golf pencil. Not really. That was just a funny fib. And we're always thankful to have guests on the show, especially when they're not real. Well, hi there. What's your name? My name's Dexter. Dexter? Oh, last name Dexter? Dexter Oath. Dexter Oath. Oh, well, it's nice to have you on Science with Mike, Dexter Oath. Would you like to hop into the Vacuuminator SCC1 to see what happens? Is it gonna hurt? Well, no, not at all. Maybe a little bit. Yeah, it's gonna hurt. Okay, if you insist, I'll do it for science. There you go, buddy. There you go, Dexter. Okay, we'll turn this on. Oh, you fell over. I feel myself expanding. My mind is expanding. Oh boy, I'm gonna push over that beaker in a second. This is how I feel like after when I eat chili. Yeah, I think, Dexter, what happened is all the little air pockets in you kind of tore open. And that's why you started going down in volume. And now we'll just kind of bring you back to regular pressure. Well, you want to sign off for us, Dexter? Thanks for watching Science with Mike. I think I need some wrinkle cream. That's some vacuum expanded goodness. Thanks for watching.